And our next speaker, the second keynote speaker of the conference and of the day, is Robert Binder. I think we have met first about 4 years ago.
That's right,
at a
yes.
model-based testing conference.
Yeah.
So I saw a wonderful presentation from you about MBT, but I think that Bob today will present us a new presentation about Agile.
Yes.
Yeah? So, please.
Right. Well, thank you very much, Timur. I want to thank all the organizers, especially those that I've had contact with. Been tremendous in getting this event going. And I'll echo the thanks that have been made by others to all of you who attended this meeting. It's really kind of special. I haven't been to a testing meeting since the heyday in the 1990s, late 1990s in Silicon Valley. The last big testing meeting I went to had about 1,200 people in attendance. I haven't seen anything like that since. So I hope this is a trend. This is great. Tell your friends, come back next year. Okay, so today I want to talk to you about a project that I'm working on that I call Agile High Assurance, which is related to a larger project that I'm working on that I'm also, for lack of a better term, calling reimagining testing. I have been working as a startup founder and consultant for the last 30 years, and recently started working at the Software Engineering Institute of Carnegie Mellon University. So I've kind of hung up my spurs, as it were. This, by the way, as the fine print says, is basically my opinion, and it's not officially the position of the Software Engineering Institute or Carnegie Mellon. So let me kind of suggest to you what I kind of think the traditional view of software testing is. This is a statue of Don Quixote and Sancho Panza. And of course, I imagine most of you are familiar with the story. Most people, of course, know that Don Quixote was the wide-eyed dreamer, perhaps hallucinating from time to time, and doing all sorts of strange things, as well as getting into all kinds of adventures. It kind of sounds like software developers, at least some of them that I know, and I'd include myself in that group. Sancho Panza was a kind of a negative worrywart. He was always advising Don Quixote, don't do that. You know, if you do that, bad things are going to happen. Or that's really not a castle, it's a windmill, and so on and so on. So he was kind of the negative antidote, and kind of the setup in the story is kind of an allegorical figure that responded to some of the more grandiose ideas that Quixote had. But he was basically derivative. So he didn't kind of advance things on his own, he reacted. And most of his reactions were critical. So if you would like to characterize what I think has been the traditional relationship between software developers and software testers, it's been somewhat like this. I don't say it's entirely like this. I'm offering this as a metaphor for what I see are some kind of common patterns. I think that actually has worked well in some cases, in other cases not, because software testing has kind of thus put itself into a box where I think its contributions are limited. And I believe that reshaping this role of testers and developers could do some interesting things. So here is another metaphor. I'm not sure if this is the right one. This is another kind of interesting relationship. I looked for lots of relationships that were kind of collaborative. And you know, I found ones like Thelma and Louise. I don't know if you're familiar with that movie. Lone Ranger and Tonto, and lots of other things. I don't know if those would translate well. At any rate, here's one where this is the android Data, of course. You may recognize it from the Star Trek series and Captain Picard. I'm not a Trekkie, so let me state that right now. If anybody wants to correct me on the particulars of what was going on here, I'm not sure what it was. Again, it's a metaphor, but I think that what it suggested to me was that there's a kind of collaboration of equals, but equals with different roles and specializations and things to bring to the table. So I see testing as taking the role of performing what I call quality attribute engineering. One of the things that the Software Engineering Institute really does a nice job of is the notion of defining and integrating into architectures quality attributes. All this stuff is public and on its website. I recommend you take a look at it if you're interested in this. What's a quality attribute? Well, it's what most people might call the ilities: performance, reliability, usability, maintainability. All of those things are called quality attributes. And they can be engineered. And in particular, we can define ways of identifying whether they're present or not. Well, once they're identified, that's a requirement, and the validation of that ought to be, I believe, the job of test. So test can have, I think, at the start, a kind of interesting relationship there. Test is also, in my mind, primarily about risk reduction. So the role of test within the software development process is to advise the sponsors, or the people who release the systems, of whether or not, or what is likely to happen if they release the system with respect to its intended performance and use. Is it going to embarrass you? Is it going to cause a large financial loss? Does it have the chance of doing that? Can it hurt somebody? Or is it going to make you a ton of money? Or is it going to help you rescue people who are in dire situations? And then finally, there's an interesting idea. With some of the things we alluded to just a moment ago, yes, there is an awful lot going on in the technology space. And we're going from kind of an idea, I think, in what we want to do in systems of asking the question, does the system produce the right answers at the right time, to whether or not we can trust it to do what we intend it to do. And I'll mention some reasons why this is kind of more of a, I think, a coming to the more pronounced role. So this is kind of how I tend to think about software testing, at least in its most valuable form. All right, so today I want to talk about some risk drivers. I want to give you a quick review of Agile testing practices. I assume most people here know what these are, so I won't spend a lot of time on this. I want to do that mainly just for level setting. I want to talk about a technique that I'm calling Agile High Assurance, and then get to a conclusion. What drives software risk? These are some of the factors that were just alluded to a moment ago, and my take on this. Oceans of code. Huge amounts of code. The typical automobile, and I have this from a guy who leads this at practice for Bosch, Mercedes-Benz, BMW, Audi, and some other manufacturers. The typical automobile today, low-end or middle-end car, has on the order of 50 million lines of code. This is a fact verified. And the expectation is, within the next several years, that will double. So the car that you back out of your driveway in the morning and go off to wherever it is you're going to, 100 million lines of code. That is astounding. At least it is to me. GitHub is another phenomenon that has kind of an indicator of this. GitHub started out about, almost 7 or 8 years ago, kind of a hobbyist project, and now has become a global phenomenon. There are, at last count, I couldn't really find any good numbers on this, but my estimation is that there are about 12 million repositories hosted on GitHub. So people are producing lots and lots of software. Now the question is, what's the role of test in all this? And I'll try to get to that in a minute. Cyber insecurity. We talk about cybersecurity. I think the state of the art and the state of the practice at this point, it'd probably be more accurate to characterize it as cyber insecurity. Because there's a new headline almost once a week, sometimes more often than that, of some phenomenally large criminal activity or other kind of nefarious act that is enabled through breaches of security. There is unprecedented connectivity. Unprecedented. All of you have mobile phones that have a huge amount of bandwidth. We heard from Nokia this morning that they're planning on increasing that by 3 to 4 orders of magnitude. And not only so that you can talk to your friends and take more Snapchats, the better to do that. But now you can send your Snapchats to your refrigerator. I'm sure it'll be interesting. The point is, unprecedented connectivity. And this is generating, again, huge amounts of data. Huge. Personalization. So the amount of, if you think about what's happening with your handhelds and how the human experience of computing has gone from computers as kind of often walled off in a computer room, interestingly enough, much of the functionality that we have today is a result of that, but it's now personalized, and you have this amazing device. I mean, I've been in software a long time, and I'm just kind of gobsmacked sometimes when I think about really what's on that iPhone 6 that I've got. So the personalization aspects of this with data are really kind of shaping behavior and businesses and governments in very interesting ways. Deployment acceleration. We've heard about this in several forms today. But it's not getting slower. The pressure and the inclination, the movement, everything, that cycle time, the pressures are to make it faster. And even if you work for some enlightened management who said, you know, we really want to give our developers an adequate amount of time and testers to finish the job right, your organization is under competitive pressures where people are saying, the heck with that, we got to get this stuff out or somebody else is going to eat our lunch. And it won't really matter anything else if we don't meet that deadline. So deployment acceleration is a fact of life. And I don't see it stabilizing anytime soon. And another kind of just the last one, sort of a driver in this, is autonomous systems. These are systems that basically you ask them to do something and they start working it out on their own. So if you have seen the Roomba vacuum cleaner, right? Goes around your house, finds the dirt, vacuums it up for you, that's an autonomous system. The autonomous systems that are coming down the road are going to be much smarter, much more capable, and do a lot more interaction. So this is great, right? We're living in an age of miracles, I think, of a sort. But there's an awful lot of risk in all this. There's a lot of stuff, and there are just lots more ways that it can go wrong. Recommended reading for you on this. If you really want to get some excellent kind of perspective on what really is driving this information technology, I recommend Mary Meeker's report. She works for Kleiner Perkins, which is one of the absolutely kind of core venture capital firms in Silicon Valley. You can download this report. It's really very interesting reading. Here are some notional risk profiles. I break up computing into three basic spaces. Personal, and by that I mean all the stuff that goes on your handhelds, as well as what you have as personal apps on your computer and so forth and so on, things that primarily serve purposes of interest to you. So that would include smartwatches and so on. Then there's enterprise IT, and we know what that is. That's basically things that drive transaction processing, pay the bills, make sure that the materials get where they're supposed to, make sure that when I get on an airplane that my baggage actually arrives in Budapest instead of somewhere else, which it did. And then there's embedded systems, and embedded for me covers a very large range. So things that basically we're interested in the interaction of software and a device as opposed to a person or a process. So what are these things, curves that I've drawn here are really kind of to suggest where I see the bulk of the applications falling. So in personal computing, on the bottom, by the way, it's kind of a scale of risk of failure. So on one hand, we have nuisance failures. So that's where your iPhone, you're in the middle of a hot session of Angry Birds, and it just kind of burps and stops and freezes. Well, you're an angry bird for about 5 seconds, but really, is it a big deal? It's a nuisance. And then there are things up to existential loss. In other words, something that is so severe caused by bad software that a person or organizations will cease to exist. They will be destroyed. This recently happened in capital markets, which is a space that I'm very familiar with a firm called Knight Capital, who released the wrong release of a piece of software. It was supposed to be in test, and it generated orders for test, but they put it into production. After about 3 hours of trading on that, they had sunk their firm, which had $1 billion capitalization. They put themselves out of business in 3 hours. This is a firm that was one of the kind of bedrock member firms of the New York Stock Exchange. And I'm sure you can come up with plenty of other examples. So that's kind of the spectrum of risk. So the question about software is not what methodology you're doing, what tool am I using, it's kind of where do we come down as testers in helping people decide where they stand in this spectrum. Personal computing, most of the apps, and by the way, these distributions, they're skewed. I would say that most of the apps, out of the entire population of apps, of which there's a huge number now, most of them are, if they fail, it's on the nuisance side. There are a few that are critical. Enterprise IT, businesses usually don't spend money on something unless it's important. So hence, I'd say that most of the enterprise IT apps are somewhere between existential loss and nuisance. And most embedded systems have the ability to do really bad stuff if they get out of control. And certainly there are lots and lots of safety-critical embedded systems. So I'm talking about risk. This is kind of what I have in mind. And the focus of what I'm going to talk about, Agile High Assurance, is on this end, this right-hand side of this graph. So there are lots of other things to be said about these other areas, but it's not my area of interest in particular. So let's quickly talk about Agile testing practices, quickly. You probably have all seen this picture. This is a very nice picture produced by Janet Gregory and Linda Crispin. It's in the Agile Testing book. It essentially lays out kind of technology-facing versus business-facing kinds of tests. And it sort of is an inventory of all the kinds of testing that is typically done in an Agile project. I'm not going to go through this because I'm going to assume that you're probably familiar with most of these. And I'll talk a little bit about several of these. The key thing to note about Agile testing or Agile development is that Agile, and this is a technical term, inter-twingles development and test. In other words, where even in iterative development, we had the idea, as Grady Booch put it, of code a little, test a little, design a little, code a little, test a little. This is kind of not the way it's done in Agile, where testing and development are basically move forward in lockstep. And you can see here that this is, by the way, kind of adapted from the Scaled Agile framework, also known as SAFe, which I kind of like as a way of thinking about Agile and big projects. So you can see that we have each of these little trapezoids corresponds to a sprint. Let's take a look at what's inside of this sprint. Inside of a sprint, we have sprint planning, and then there's an activity called story writing, for lack of a better word, and story testing. So those two things kind of move in parallel. There's not kind of a linear relationship. Implementation it also has a similar relationship where developer testing and continuous integration goes hand in hand for the duration of the sprint. You finally produce working software at the end, and you do a demo, and everything is sweetness and light. Yes? I guess you all agree. Okay. Let's take a look at some of the frequently used Agile testing practices. You're all familiar, I'm going to assume, with test-driven development. We're going to talk a little bit about this. It has several cousins, behavior-driven development. There is automated testing that is really kind of a common part of this practice. There's a list of tools. Many of you are familiar with them. Exploratory testing is another key element of this. The idea of living tests that are not kind of documentation that is basically obsolete as soon as it's finished. Concurrent development and testing, so testing and development are kind of move hand in hand. And then there's the idea that bugs really shouldn't escape a sprint. So you should find the bugs, you find a bug in a sprint, you fix it. So you keep the find to fix interval as short as possible. Test first development works kind of like this. So, and by the way, somebody mentioned build lamps this morning. Oh, so this is the original build lamp. Picture from a startup that I was a technical advisor on the technical advisory board, Agitar, which produced a product called Agitator. It was quite interesting. And they had lava lamps as build lamps, controlled by an X10 automation system. So if the build broke, the lava lamp, the red lamp lit, the build worked, the green lamp was on. So you're probably, I'm going to assume for most of you are familiar with this process of how test-driven development works. You first code the test, you run it, the test should fail. Then you code the implementation, you rerun the test, and we expect that it's going to pass. So we basically follow that same procedure. We test the next method, it should fail, and then code the implementation, it should pass. Rerun all the tests, and the same thing for the final one. So that's test-driven development. Now the red-green pattern, as I call it, is the same cycle is used for test-driven development, or behavior-driven development, and acceptance test-driven development. I'm not going to talk about those in particular at this moment. There's another idea called exploratory testing. And in here, the tester does not follow a specific planned test procedure. You interact with the system under test. You try to provoke it to produce bugs. It's opportunistic. And if some people use the idea of a tour, which is a kind of a notional way to focus on particular aspects of the system under test. Exploratory testing also has the notion of critiquing. It's great for user interfaces. It's really not much use, in my opinion, at all for anything else. So we can ask the question, it's kind of an American colloquialism, how's that working out for you? It's a study done by a guy named Don Reifer last year that answered that question in kind of interesting ways. So these are counts, and deference to my good friend Lee Copeland, I think numbers actually can mean things in certain circumstances, and if we don't have numbers, what do we talk about anyway? These are average post-release bugs per 1,000 equivalent lines of source code by different industries. These are based on a survey of about several hundred firms that Reifer regularly corresponds with. So you can see there's a fair range. And mobile apps were kind of assumed to be the worst. I didn't put those commas in there. Interesting. Localization at work. And the others. And this means, of course, that in aerospace we had something less than 1 bug per 1,000 lines of code. The interesting thing here for me is that there's not much difference between traditional, in other words, the dreaded waterfall, between traditional development and Agile. One can speculate as to why that might be. I have my own ideas, but it is the fact as Reifer, who is quite an advocate for Agile development, reported them. This has some interesting implications for me. If we predicted, let's assume that we're writing about a 500 KLOC Java application. These days, that's a relatively small system. How many bugs, after we'd gone and applied these test practices to that system, how many latent bugs would there be? So if you just do the simple math, this is the number of latent bugs. And if it was aerospace, this is going to be flying your next drone or airplane or autonomous system, probably. 325. Medical, closer to 1,000. IT, 2,500. All right, so let me ask you this. How many of those do you think are severity level 1? Showstoppers, catastrophic, safety critical. 1%? How many is that? Too many. So the question is, we have evidence, I think, that Agile practices are doing about as well in terms of quality overall as other established practices, but in my estimation, not well enough. So, on top of that, if you talk to people who do a lot of testing in the Agile community, they will start to confess in a sotto voce that there are some problems. There was quite a controversy that erupted last year about test waste, and that test-driven development was seen to be as a questionable practice. I won't rehash the arguments for that. If you're interested in it, I can point you to it. One thing that I've seen, and I think everybody's seen, is that there's very high variance in the kind of design and level of testing that is achieved in test-driven development. That's because Agile practices do not really ask for any kind of concrete definition of done. The definition of done is, for the most part, subjective. So you get some people who are quite good at test design, and you get other people who are really awful at it, and you get lots of people who are kind of in between. The idea of a story is great. I really must say that I cringe every time somebody says this is specification-based development. It drives me nuts. Maybe that's just my own quirkiness of personality, but it really bothers me, because to me a specification is an abstraction. A specification is something that defines the entire space of inputs and outputs. When we say that a test case is equivalent to a specification, I think it's completely ludicrous. Why? Because it's one instance. It's one instance out of a huge space of inputs. One or two or a dozen or even 100 instances. It's still a very small set of the possible inputs that can be applied to any kind of interface. So, to my way of thinking, it really is not a specification. It's an example. The examples are useful. The examples are useful for prompting people who are good at software development kind of figuring out the rest by implication. But there are a lot of reasons and a lot of times I think we ought to be explicit about it. Exploratory testing is great, but the problem with exploratory testing is that often the insights that are generated evaporate. It's like a jazz musician that I used to like said, music goes in the air and then it's gone. So exploratory testing, unless there is some kind of recording, which is fairly simple to do, causes its effort that goes nowhere. Testing is still squeezed. Now, if there are any of you in this room who do Agile testing and have not had kind of your amount of time to test reduced, as was suggested this morning by one of our colleagues, please let me know. I'd like to understand what it is that you're doing to prevent that. In all the teams that I've worked with, there has been schedule pressure, despite the best attempts and best well-meaning attempts of people involved not to do that. And then there's something that I call the testing BackBlob, eating many teams. What is that? I observed this several times and kind of figured it out that, let's say that you start out in sprint 1 and that you have some number of hours, some number of persons to do the work of testing. And during that sprint, they do that work and they produce a certain number of test cases. Well, what happens in sprint 2? They essentially apply the same amount of effort and produce roughly the same increment of test asset deliverables. And sprint 3, the same story, and in sprint 4, the same story. Well, that's the total developed test cases. Now, if these test cases happen to be manual, can that test team re-execute all of those test cases they developed? No. They can do some proportion of them. They can't do all of them. And by the way, the difference in those two distances between that bar and the purple triangle is usually the amount of overtime that the testers end up putting in towards the last sprint. The same thing happens for automated test cases because they tend not to be maintained. There is basically an assumption that either they're fine or we just don't need to, if they have broken because something has changed and things change because there's churn during the sprint, well, we'll just not re-execute them. So this exposes you to a lot of risk from regression bugs and also diminishes the level of coverage. And then there's this great set of tests that everybody has developed, which basically go nowhere. This is testing BackBlob. I have a more extensive discussion of this, which is based on a 1957 B movie where this kind of reddish blob of goo ate a small town in Southern California. It's one of those 50s science fiction movies. It was kind of a classic. Okay. So what to do about all this? My thoughts on this at present, and this is very much a work in progress and evolving, and I'd be happy to discuss this with anybody after the talk, All right, so let's go back to our notional risk profiles. Again, I want to emphasize the area of focus of Agile high assurance is on these things that tend to have high consequences. So I want to talk to you about strategy, what goes on in development sprints, goes on in test sprints, and some relief points as opposed to pain points. So here's a key idea. And if there are some of you are Agile advocates out there, if this makes your head explode, I apologize in advance. I have a good reason for doing what I want to do, and I hope to convey that to you in just a few moments. The key idea of Agile high assurance is staggered and standalone test sprints. So where in a typical Agile project, all testing goes on in the context of a sprint, I want a separate sprint that does testing and does nothing but testing. That doesn't mean that the developers stop doing testing. What I want the developers to do is pretty much what they have been. But I want to actually relax what they ask from them, with some exceptions. We'll see. All right, so that's one basic idea. We have a development sprint, which does pretty much the same thing it's been doing so far, and then a test sprint. If we kind of look at this in time sequence, you begin to get the idea. So the developers are working on version n.1. The testers are preparing to do testing. For developers are working on version n.2. The testers are testing version n.1. And then kind of in all of its full and horrible glory, here is kind of the way that this flows throughout the cycle. So you can see the kind of moving forward in the cadence. Testing, by the way, stays on the same cadence as development. And the pictures are suggestive here to indicate that test consumes the output of a development sprint, tests it, locates bugs in it or does not. Those bugs then become input to the sprint planning and become part of the backlog for the sprint N+2. So this is the idea. There's also something I'd like to point out is that the backlog that testers work off of is a separate backlog. So it's a backlog that defines their work as testers, not the same work that developers do. Although, of course, those are derived from a common point, the program backlog or system backlog. All right, so when I first presented this to some of my friends who were very enthusiastic about Agile, they said, God, that's awful. How can you do that? Well, I said, think about it like this. Here's a metaphor. There are several ways to organize teams. In the United States, we play hockey and lots of other things. We play a game that's called football. It's not the same as your football. But as a metaphor for what I'm talking about, you could look to hockey as a kind of game where the players switch between defense and offense depending on where they are on the ice. Same thing is true of basketball. Soccer follows pretty much the same rule. Lots of games do this. So there's not a separate defense and offensive team. Players pick up different roles. And to me, that's kind of analogous to what goes on in Agile development. So developers do testing. Testers don't do development, but they do testing in the context of development. So remember, I said they're inter-twingled. The only true defensive player on a hockey team is the goalie. This is, of course, the Chicago Blackhawks drubbing the hated Philadelphia Flyers. In US football, there are two separate teams. And this is, for those of you who may never seen something like this before, this is not a software engineering diagram. This is a play chart for a football play. The diamonds indicate the players that are playing defense, I think. And the circles indicate the players that are playing offense. The two teams alternate. So one team has both an offensive and defensive units. The other team has offense and defense. Here's, I think, the greatest offensive player in NFL football of all time, Walter Payton, flying over the hapless Detroit Lions and their defense. The only time that players switch between defense and offense in a US football game is on a turnover, which happens infrequently. There is some exception to that. So to kind of think about classic Agile, I think about it as similar to the way that a hockey team works. Testers and developers work on the same backlog. They're part of the same team. Testers do mostly manual testing. Developers do TDD and BDD and some exploratory sometimes. Testers typically perform acceptance test-driven development or comparable functional testing of stories, and they're often specialists who do security and performance testing. And one of the key ideas in this is that team coherence, the interaction between testers and developers, is really critical and key to this, and that kind of interaction really drives things. And this notion of Agile high assurance, testers are members of a test team, not the dev team. They both work similar to the idea of defense and offense in US football. They're members of the same team, but they play distinct and different roles. Most testers are what are referred to as SDETS, which is a Microsoft-ism originally. It means software developer, development engineer in test. It's kind of an ungainly mouthful. It essentially means a person who is skilled and adept as a programmer who has become a person who does testing, and usually automated testing. Developers still do TDD and BDD, record their explorations, and then achieve three-way coverage. I'll explain more about that in a moment. Then the testers take the result of that, roll that into a model-based testing suite, and extend it. The test team is responsible for quality attribute testing and engineering if necessary. And high coverage, high stress testing of the system is seen as the key to high quality. So here are kind of the contrasting views. So what I'm going to do next is to kind of go through these what, why, and how. I will go through these fairly quickly, and no, there won't be a quiz at the end of this, so you don't have to read everything. Let me just try to give you the gist of the idea. So why do we want staggered standalone and test sprints? Because, as was kind of suggested this morning, I thought this morning's talk about Agile development was quite interesting because it outlined the problem quite clearly. And that is that testers really are still kind of they're sort of the Sancho Panza, right? They're the guy that kind of comes along, cleans up afterwards, and kind of complains about, you didn't do this, you didn't do that, and the developers say, okay, all right, I'll fix it. Test never really gets outside the context of development. So a test is always kind of what we refer to as the third wheel in a development sprint. I believe for tests to kind of take the role that I think it should, they have to be on equal standing. So that's why they're staggered and separate. Testers, this the one thing that's key. If you've done testing for a while, you know that your life is made much more complicated and difficult if what you're attempting to test changes all the time. What happens when you're testing in a sprint? There is continual churn of the code. That's what's supposed to happen. So when do you get a stable, fully built out implementation to test? As we heard this morning, usually on the last day of the sprint, or maybe 3 days before. Say, okay, there it is, test it. You got it, I'm gonna rip through my test. And if you have time to do that, by the way, you're probably not gonna have time to do the test you did in the last sprint. So giving testers a space to focus on a stable target is really important. And another part of this is to empower testers to do high-quality work. This achieves what I call horizontal and vertical scaling. What does that mean? Testing is not limited to the extent of the dev backlog team size. So right now, how much testing can you do? If you have to increase the amount of testing you have to do, you have to, in this sort of standard Agile model, you have to add another development sprint. You can add testers to a sprint, but there's kind of a recommendation not to get the, have the testers, 5 developers and 50 testers. So how do you handle that if you want to scale testing? It's a problem. Well, with this, it kind of solves that problem, I think. This is a way to defeat the testing squeeze. And Sometimes, as you probably know and maybe have articulated to your colleagues in development, the scope of testing work is actually not just running tests. It's developing the testing infrastructure, it's test design and implementation, and it's execution of regression tests and their maintenance. So if you think about that, just kind of in contrast to the work that developers do, I would say that you can make a case that it's 3 times as much. The test team, I argue, ought to be composed primarily of SDETS. Why? Because I believe that test automation is fundamentally an application, it's a specialized kind of application development, test automation. It should not be done by people that don't know how to do programming. Test environment needs focus, and you need a runway, as it's called, to build the test architecture. SDETS are the people that I believe are best qualified to do that. So I would say it's just kind of an off-the-cuff recommendation, 3-to-1 SDETS to testers and the test team, and 1-to-1 otherwise. Test asset management system. In larger programs, you need the ability to coordinate and communicate information. I think some others have touched on this earlier today. There are about 65 of these tools actually available. And by this, I mean something like a common example is HPALM. There are others, a tool from SmartBear. IBM has Quality Manager, I believe it's called. There are several open source tools. There's a nice one, the name of which escapes me, from a Spanish development house. Lots of possibilities here. Why? You need a couple of things. You need a release decision support system that has the so-called truth at system scope. You need to have the ability to support program-wide or multiple project-wide dashboarding. And you need to manage multiple teams so that you don't end up with a lot of redundant, conflicting, or omitted artifacts. Risk management decision support. As I said a little while ago, I believe that the primary role of test is to perform risk management or to help the program sponsors achieve that. And how do you do that? You tell them what you find. You investigate. You find out. You are responsible for making an assessment of what's going to happen if they release the system today or with making some assumptions 3 weeks from now. Is it going to do what it's supposed to? Are we going to make a bunch of money? Is everyone going to be happy? Are we all going to get promoted? Or are bad things going to happen? Is your company going to go out of business? Is somebody going to get hurt? So test has the responsibility of producing that kind of information, not just kind of, I see test's role as not so much of the primary one of being a kind of a team player, but of somebody that supports the decision makers and the sponsors of the system. And this is essentially compliance on quality attributes and system completeness. Why? I think test is best positioned to do this. They have the information, or at least they should. Okay, development sprints. What are the developers doing? They document stories with BDD. This is nothing new. BDD I like, it's widely used, there's no friction, it's practical and traceable. It establishes the basis for a test model. My complaint about BDD, as I alluded to a moment ago, is that it's incomplete. It is not a specification. It's a bunch of examples. There's lots of BDD tools out there, most of them have interfaces with TAMs. I'd like the developers to start using, and again, I'm talking about a high assurance environment here, a three-way coverage definition of done. So that includes code coverage, clean report from static analyzers, including security static analyzers, and achieving a minimum mutation score. Mutation is another way of learning about your test suite, which is not dependent on anybody's opinion. It is very good evidence as to whether or not the test suite that you have constructed is actually likely to have found bugs if they exist. Each of these things, by the way, can be dialed up and down in terms of quantitative numbers with an impact on the amount of work to be done. I think another key, the reason that this is in here is to reduce the systemic variation, if you want the quality assurance model term. I mentioned a moment ago, one of the weaknesses, I believe, of the current testing practices in Agile is that you have a huge amount of variation in the quality and extent of test suites that are produced. This reduces that down to where we have kind of a common standard for them, and we know what we're getting. And of course, I would argue this, other things being equal, substantially reduces the risk of escapes. I want the developers to do exploratory testing in systems that have a user interface. Do exploratory testing, record it, and hand that off to the testers. But don't write any test automation code yourself. Why? Because in every circumstance that I've been involved with, when developers also try to write test automation scripting, it usually doesn't turn out well. And they've got better things to do anyhow. So if you have a team of specialists, people who really know how to do that, and it is a speciality, it's not something you just kind of pick up and start doing, you know, this afternoon if you feel like it. This avoids, I think, the testing BackBlob, because it takes the problem of managing that growing set of regression tests and hands it off to people who can factor a code base for test in such a way that it is minimal and reusable. What do the testers do? Test abstracts stories as models. So I'm not saying we abandon anything that's kind of current practice in Agile, but what I do ask is that we take that beginning, that first approximations, which is what I believe stories are and feature files. It's a first approximation to a specification. Let's turn that into a test model that defines a behavior in all its glory. Once we have that, we can then start to explore the models using a model-based testing tool or traditional test techniques. And by the way, I want to stress again that stories are wonderful vehicles for articulating in a concise way a particular user want and an idea about how to achieve it. Remember, it's only one instance out of a very large number of possible interactions with a particular interface. In this, I think we should prefer model-based testing. We've heard a little bit of discussion about it today. I won't belabor the point. There's a lot to say about this technically, but what I want tests to do is to develop test models using one or more MBT tools. By the way, hashtag more models, less tests, that's mine. So what does that mean? In other words, I think it makes more sense to do testing by doing more modeling and less manual testing, less hand-coded testing. Model-based testing has a lot of good benefits. It's not a panacea. It's not a cure-all. It's not a silver bullet. You will still need to do manual testing. You will still need to do hand-coded test suites. There'll be plenty of reasons to do that. It doesn't replace any of that. But the preference and the focus should be on that. There are about 10 model-based testing tools available today, including commercial off-the-shelf as well as free open source. And they work well for embedded or IT systems. All right. Another thing that I think is critical is test is responsible for developing a sustainable, maintainable test automation framework. Key parts of that are mocking, service virtualization, and emulation. By the way, I went to a talk earlier this afternoon, and I saw a very interesting open source system from the guys at, what is it, EPAM? Yeah, there he is over there. Really fantastic tool for doing virtualization, at least according to the PowerPoint anyway. I commend you to take a look at it if you're working in this space and you want something as an alternative to other products that tend to cost a lot of money. So tests should be in the business of doing this or getting tools in and integrating them and do this. They should also be in the business of devising what are called adapters, sometimes known as page objects, and other kinds of test tool glue. This can all, if you do this right, it's a framework, it's integrated, it's not kind of a hodgepodge. That's why it's important to have people who are good at software development, software engineering doing it. All right. This is kind of a corollary to that. The test produces UI automation. So we take the developer explorations, we abstract and build on them, we factor out of them the commonality so that we have reusable test assets. And the rationale for this is that bad UI test code is one of the big drivers of test cost. I'm sure many of you have experienced this, where you have produced a library or a suite of automated tests for a GUI, becomes highly brittle, becomes too expensive to maintain, and you just walk away from it. You abandon it. That's a fairly common occurrence. We don't want that to happen anymore. This takes skill in doing this kind of software engineering. And then finally, test exercises what are called quality attributes. And I believe this is where test can really kind of define. Quality attributes include, by the way, functionality and correctness. So it's not just the ilities. Functionality is one of the quality attributes. But it's not first among equals. It's one of many. And so one of the things that I've seen time and again, a missed opportunity in testing, is where we do functional test, we stabilize system and functional system test, then we go do performance testing later. Performance testing takes maybe one or two functions or a sample of test cases and just kind of rubber stamp repeats them. Well, that's useful for certain things, but I've found that it is much more effective to interleave comprehensive functional testing with very high load and stress. If you really want to scare the bugs out of your system, this is what I call multidimensional testing. That is a way to do it. That takes good test automation. It takes a kind of sophisticated application of model-based testing to do, but it can be done at the same time. Why? Quality attributes are often underspecified or not specified at all. When the testing is done, the testing is usually done late or it's superficial. And often we need specialists to achieve it where they're in short supply or they're non-cooperative for some reason, or there's all kinds of headaches that can happen with this. If this becomes a routine part of what the test team does as early as possible during the development cycle, as early as possible in one of those sprints, a lot of those problems are mitigated. And then finally, I think there's an opportunity for tests to do this. One of the big bugaboos of software over the long haul in maintaining a software system is usable as-built documentation. So I kind of agree with the Agile complaint about, or exhortation to no big design up front. That makes a lot of sense for a lot of reasons. It doesn't say no design up front, by the way. But once you get done, you're not done. Once the system is working, well, where's the information and all the learning that happened in the heat of battle when that thing was put together and made to work? If you don't have some kind of documentation, all that energy just goes poof. It's gone. And that's work that will have to be repeated by your colleagues or somebody else down the line. Since test, and I mean the testers, are in the best position to understand the behavior of the system under test, they are the ones, I believe, who are in the best position to document its as-built behavior. And as part of doing model-based testing, it makes sense to do that anyhow. So I believe a role, this is kind of the engineering role that I foresee in test becoming an equal partner in development, is producing and being responsible primarily for as-built documentation. Okay. So I'm getting close to the end of my hour, so let me get to the relief points. Test, waste, variance, these are all the complaints that I talked about earlier. I'm not making this stuff up, so I'm not the only individual that complains about these things. Test, waste, and variance, we're going to look for standard criteria, three-way coverage, and evidence with we can dial in the amount of rigor we want on that. Instance-based risks, in other words, making the assumption that a story is equivalent to all possible behaviors. We would take test models and abstract behavior so that we do have coverage of the behavioral space. we lose the insights and the work that goes into exploratory testing. It's very valuable and insightful. This is a great and very powerful technique in the hands of the right people. We record that and then fold that into our test models. That drives test development later. Testing is still squeezed. Yes, it's true. You may think that because you're a tester, that is your lot in life. It's probably because you had some sort of original sin, right? That every time you get close to a release, it all rolls downhill on you. Well, it doesn't have to be like that. With vertical and horizontal scaling of sprints, I believe we can minimize the effects of that. And then the testing BackBlob doesn't have to eat teams alive. Model-based testing is a way to radically reduce the burden of test maintenance. Okay. So again, it's all about the risk. This is kind of a jokey term that was common in Silicon Valley not too long ago. It was called fragile development. Those are people who were basically in a big hurry to produce a lot of code. I'd say, okay, fine, if that's what you got to do it. But just understand that it's appropriate for certain types of applications, but not for all. Classical Agile is still fine. I don't have a real quarrel with it. I just say that I think for certain risk classes, it really is not what I would want to do. And the techniques and strategies that I've outlined for you as Agile high assurance are appropriate when there is higher levels of failure risk. Finally, to get back to my original notion about kind of reimagining what testing is about, typical Agile testing practices don't reduce the failure risk for critical systems. Agile high assurance mitigates existential risk in a substantial way, and it maintains the focus and flexibility of Agile that I think is its real main driver of beneficial effects. Okay, so it looks like I may have, there it goes. All right. Testing reimagined. We want to have a collaborative validation, verification, and testing. And by that, then I mean that testing has an equal but different role in the development process. I see focus on quality attribute engineering as one means of making that happen. Test also can take a new dimension in the development process by becoming the keeper and owner of as-built models. And by the way, test is the one that is going to care about these a lot because you have to do regression testing based on your understanding of the system under test. Developers will thank you for it eventually. So that's the end of my talk, and we have time for maybe a few questions.
Thank you. Yeah, and questions, Attila.
Very interesting idea and very interesting presentation. Particularly liked your approach. Don't you see risk by pulling out testers from development teams? Because testers are not only doing testing in classical Agile, but there are other activities like planning and estimation. And if you leave only developers and say designers, you lose the cross-functional notion of the team. And then the development, the planning and those ceremonies will miss the testing mindset, I would say.
Okay, so
what about
let me...
a hybrid model where you put at most one tester in the team, in the development team, and then you have this separate team which does testing, as you just mentioned.
I think that's a very valid point, and it's of course what most people, the first thing that I hear in response to this. I'm not saying that the testers, the East is East and West is West, and never the twain shall meet. So the testers and developers can still and should collaborate, but the nature of the collaboration is different. I'm not saying there has to be a wall between them. That's not the intent at all. It's a different way of looking at this. Some people may say, I like hockey better. I don't like American football. Not for me. So, you know, that's fine. But if you're in a situation where high assurance, you have a high risk of related to failure, I think it's an approach worth considering.
Thanks. Next question. Okay.
In your method, what is the definition of done? Because usually that includes that the tester has.
I'm sorry, could you repeat that, please?
Sure. So in this Agile high assurance, how could you give the definition of done?
The definition of done, the extent to which I change it is that developers have to produce what I call three-way coverage. That's for developers, and they also, if appropriate, produce exploratory testing, which is minimally documented as to its goals, purposes, and a recording that is replayable for the testers. Those are the only changes. Everything else is the definition of done as it exists in Agile as we understand it. The definition of done for the testers includes achieving certain testing goals, which are set as part of the overall sprint and release planning process.
Aren't that any contradiction that
Yes.
the developer said that we are done, and the next iteration, the tester said that no, you are not done because we found
that certainly is a that could occur, and you know, there are many ways that problem can be negotiated between the two teams. If it continues to happen, it's a breakdown.
Okay, thank you.
I don't guarantee that it won't. I don't guarantee that anything won't happen. I don't guarantee anything magic.
Thanks. Any other question? Yes.
Hi, thank you. On the slide about the three-way coverage, there was an expression, minimum mutation score, and it's not clear for me what do you mean by this, because mutation means so many things in the industry. I don't know what you mean by this.
I mean mutation in reference to, actually I have a particular tool in mind, which is open source. It's called PyTest. It works only on Java. There are others that do similar things. But essentially, mutation score is the number of mutations which are discovered by your test suite. So if you make 100 mutations to a program and your test suite only only registers a failure on 50 of those, your mutation score is 50%. That's what that means.
By mutation, you mean the mutation of state?
Mutation of source code. So you take source code and
entries.
You reverse. You make equals, not equals. You make less than, greater than. You make foo equal bar, foo equal foo.
Yeah. Okay, now I get it. Thanks.
Thank you. Maybe the last question. Okay.
Okay. So as far as the work is split between development and test iterations, testing, how can you predict for a given feature when it be done and be delivered?
I'm sorry, could you please repeat that? I didn't understand you.
So let's imagine that the team is working on a feature, and first the development is done, then the testing is done in a separate iteration, and the testers find some bugs. Then it goes back to the dev team. So
yes.
It makes it a bit hard to predict when the feature will be done.
I think that's a valid criticism, yes. So that is one trade-off. Like a lot of things in engineering, there's no perfect world. I think I can solve certain problems at a cost, perhaps, of introducing others and making a different kind of optimization. So yes, there are trade-offs.
Okay. Thank you again. Thank you very much.
Thank you.
Yes, I think Bob will be here today, tomorrow, so you will have, if you will have any questions, you will ask.
I'll be happy to chat with anybody. Yeah.
Finally, today I have to close this day, but before closing, I have 3 announcements. The first one, that please prepare the feedback form, fill it, because you can win some valuable gifts. So the first one, that you can win a ticket for the HUSTEF 2016. You can win foundation and advanced level exams, and you can win a Galaxy Tab. So please do it. You will have time till end of tomorrow. The next one, that maybe we have an announcement about the Nokia. Yeah? Yeah, so if you see here your name, please go to the Nokia stand, okay? And last, you can find a voucher here about, sorry? So you can find here the voucher for the beer. So we invited you for a beer, so now you can go down. The Jonas Kézműves Sörház is downstairs. This is on the ground floor, and I think this is this side of the building. So you can go directly there. You don't have to wait till 5:30, so you will get the beer now, just now. Okay, so thank you so much for today, and see you tomorrow sharp at 9. Thank you again.